Hello, Math 20-1 students. So today we are looking at lesson 8.2. Like I mentioned in the previous lesson, we'll be dividing this lesson into two sections. So today we'll be covering kind of more of just the straightforward, here's a system and we need to solve it. And the next time we'll get more into more complex questions like word problems. So again, we have a little bit of review from Math 10C to start our class today. So if you remember in the last lesson, we discussed different types of systems that we're looking at in 20-1 and the types that we looked at in 10C. So if you remember in 10C, we looked at systems that were linear, so like this, where you don't have any x squared component. As we move into 20-1, we're making it a little bit more complex by looking at linear quadratic systems and quadratic systems. So those are where one is like this and the other one is with the squared variable, or where both of them have a squared variable. So in order to kind of think about what we're going to be doing today, which is where we're going to be solving, if you remember in the last lesson, we looked at solving graphically, so just entering things into our calculator and finding the points where the graphs intersect. Well, today we're going to be looking at solving them algebraically. So a little bit of a difference there today in how we solve. So if we want to solve, there's two methods that we looked at in 10C, substitution and elimination, and you need to be able to use both for all of the types of systems that we'll be looking at today. So to kind of remember how those solutions work, let's first of all work with a linear system. That's kind of like a nice easy one that might refresh your memory from 10C. So the first thing we want to do if we're solving by substitution, basically with substitution what we're doing is we're picking one variable that's easy to isolate and setting it equal to everything else. So we're isolating this. So if we look at our different variables in these two equations, the ones that have coefficients are usually the harder ones to try and isolate. So if you can find a variable that doesn't have a coefficient, that's the one you want to go with. And basically you just want to get it on its own to start out with. So in this case, that means we would need to subtract 4y from both sides. And when we do that, we're going to cancel it out here and we're going to be left with x being equal to 6 minus 4y. Now the reason we're doing that is because the second thing we're doing, just like the name implies, is we're substituting the value for x that we find in this equation into the value of x for the second equation. So if we say x is equal to 6 minus 4y, and x is a component of the second equation, we can substitute the equivalent value for x into this expression. And then because we'll only have the one variable, which is y, we can isolate and solve for y. So let's go ahead and do that. So we're going to have 2 times by x, which we said is equal to 6 minus 4y. And then subtract off 3y equals 1. So we're just substituting in for this x, our value here. Now all we need to do is simplify the expression to solve for y. So the first thing we want to do is multiply out our brackets. So 2 times 6 is 12. 2 times by negative 4y is negative 8y. Minus 3y equals 1. And then we want to combine any like terms because we've done all of our operations. So negative 8y minus 3y is negative 11y. So we're going to have 12 minus 11y equals 1. And now we just want to work to isolate that y value. So we could move the 12 over to the other side. So that means we would subtract 12. 1 minus 12 is, I'm going to go this way, negative 11. And then we're left with, on this side, still the negative 11y. So negative 11 is equal to negative 11y. Now we want to isolate this y, so we need to divide away negative 11. We need to do that on the other side as well. These two are going to cancel out, and we're left with y being equal to negative 11 divided by negative 11, which is 1. So now we have our solution for y. The next thing we want to do is, because remember with our solution we want a value for both x and y, so we can solve for x now by substituting y back into one of these equations to solve for x. So let's say we'll substitute it back into the first one because it's nice and simple. So x plus, actually, and what we can even do here, I might do that to make it easier. Because we want to solve for x, we want x isolated, which we already did here in this first step. So I'm just going to say x is equal to 6 minus 4 times by the y value we just solved for, which is 1. So basically x is equal to 6 minus 4, which is 2. And so there's our solution. Now, once you have this, if you want, you can always go into your graphing calculator and enter both of these and make sure that that's the point of intersection. So basically going in and solving graphically the way we did in the last lesson. So I'm not going to review how to do that again. But just so you know, like if you're working on homework, I would not recommend doing that because you can just check the answer in the textbook solutions. But if you're on a test, just keeping in mind that that's a way to make sure you did your solution correctly, because sometimes it's easy to make little mistakes with your numbers there, and you don't want to have something like that ruin a question on the test for you. So this time we're going to solve the same system, but we're going to use it, solve it using elimination this time. So in using elimination, basically what we're doing is we're adding the two expressions together, but we want to manipulate the expressions so that there are basically at least there's one of the variables that is equal in like its coefficient, for example, but opposite in sign, so that when we add them together they cancel out. So like if we had negative 2x here plus 2x, those would cancel out. Then we would be left with like the y terms and the numerical terms to combine. And that would lead us to a position where we could solve for y the way we did in the first one. So in this case for elimination, let's see, we would go, I'm going to do exactly what I just said. I want to make my x variables the same so that I can cancel them out. So in order to make them equal but opposite, I need to multiply this whole equation by negative 2. Okay, which means I also need to multiply the other side by negative 2. So I'm going to have negative 2 times by x plus 4y equals 6 times by negative 2. Okay, so I'll just multiply that out. Negative 2 times x gives me negative 2x. Negative 2 times by 4y gives me negative 8y. And 6 times negative 2 gives me negative 12. Now I want to add my other expression, so 2x minus 3y equals 1. And so basically I'm adding these two equations together, the like terms. So negative 2x plus 2x is 0, so that cancels out. Negative 8y plus negative 3y is the same as negative 8y minus 3y, so negative 11y. And negative 12 plus 1 is negative 11. And so we end up with the same thing we got here. We just want to divide away the negative 11, and we end up with y is equal to 1. And then we would just do the same step where we would substitute in our y value into one of these equations to solve for x. Okay, so basically the same set of steps as we followed before after that first stage of elimination. So either one of those methods you need to be able to use. For example, in a test at the end of this unit, what you would likely be asked in like a written question, for example, is to solve this system by elimination or solve this system by substitution. If you don't use the proper method that's asked for, you won't get full marks for the solution. Actually, you'll mostly not get the marks. So just make sure that you know how to use both of them. Even if you have, like for me personally, I prefer substitution, so I use that if I have the choice, but you do need to still know how to do both of them. It's one of the curricular outcomes. So let's go into an example of solving a more complex one. So here we can see we have a system of equations, linear and quadratic, and we want to be able to solve them using either one of the methods we just talked about. So for substitution, again, you want to pick what's your kind of like simplest equation and the simplest variable in them. So linear is always more simple, so we're going to work with this equation to find a substitution, and y is the variable that does not have a coefficient. So in order to isolate that, I'm going to subtract 3x from both sides, and so that's going to leave me with y is equal to -9 minus 3x. Okay, now that I have that variable, I can substitute it into my second equation. So I'm going to have 4x squared minus x plus y is now -9 minus 3x. And that is equal to -9. Okay, so now I want to go through and see if I can combine like terms. 4x squared, there's no other squared term, so that will stay the same. Negative x, so just remember to keep that sign with the variable that you're looking at. Negative x plus negative 3x, right? That's the other like term. So basically -1 plus -3 is -1 minus 3, so -4x. Plus -9, so -9, is equal to, and on this side we have -9. So now what I want to do is, whoops, I forgot to put my squared in there. Because I have a quadratic, I want to set it equal to 0 because that's the easiest way to factor it. So basically that means I want to get this -9 onto the same side as the expression. So I would do that by adding 9 to both sides. And since we already have a -9 here, that's actually going to leave us with just 4x squared minus 4x is equal to 0. So if we have a quadratic like this that doesn't have a numerical term, we can't do our normal factoring. So all we want to do is factor out as much as we can out of these two terms. So the common factor to both of these is 4x. So we're going to pull that out. 4x squared divided by 4x just leaves us with, whoops, sorry, I don't know why I put an equal sign there. I need a bracket. Okay, 4x, there we go. So 4x, what would we multiply it by to make x squared? Just another x. And what would we multiply 4x by to make -4x? -1. Okay, equals 0. So there's our factored expression. Now we would just, in order to solve for x, remember we just need to think what values of x will make this statement true, so will be equal to 0. Well, if something that's multiplying by an entire bracket is equal to 0, the whole equation will be 0. So basically if x is 0 here, this equation will be true. And then also, if what's inside the brackets is equal to 0, the whole expression will equal 0. So to make this equal to 0, we would need +1 minus 1 will equal 0. So the other possible solution is that x is equal to +1. Now we have our two values for x. So remember the next step is just to substitute our values in to solve for y. I'm going to choose my easier expression again here. So 3x. In the first one we said x is 0, so 3 times by 0 plus y equals -9. So 0 plus y equals -9. So basically y is equal to -9. So that means the coordinate of one solution, the point where these two graphs intersect, would be where x is equal to 0 and y is equal to -9. Okay. The other solution, x is 1, so we're going to have, actually I'm going to use, just like I showed you on the previous page, I'm going to use my rearranged one just to make things easier. -9 minus 3 times by 1. So basically -9 minus 3, which gives us -12. So that means my second solution would be at x is equal to 1, y is equal to -12. Now before I started, I did go ahead and put these two equations in for y. So this is where if you wanted to verify your solution graphically on a test, for example, I used the one that I rearranged here, and then I also just rearranged this one to be set equal to equal to y. And then I went to the graph. I had to play around with the windows a little bit so you guys would see it more clearly. If you guys are on a test and you're doing this, look at your solution and use that to set up your windows appropriately. Okay, so you can look at that so you're not just trying to like play around and figure out where the graphs are. So if I look at this, we said that our points of intersection should be at x equals 0, y equals -9, and we see that that's accurate here. The other one would be at x is equal to 1, y is equal to -12. And again, I'm not going to run through the intersection procedure, but you can see basically that that's correct there as well. So now we've verified that our solution works. Okay, we should be able to do the same thing using elimination. So basically what we would do is we want to set our two equations so that one term is equal. If we look at what we have here, this one, I wouldn't use x personally because this one has 3x and that one has -x. This one is positive y and positive y, so I'm just going to multiply one of these by a negative value to basically eliminate them. So I'm going to do maybe the second one. So 3x plus y equals -9. And then the second one I'm going to multiply by, I'll actually do it over here and then I'll write it down over there. So negative times by 4x squared minus x plus y equals -9. So don't forget always to multiply. If you multiply the equation through by a negative or by any coefficient, make sure you do it to the second side as well. So that means we have negative times by 4x squared is -4x squared. Negative times by negative is positive x. Negative times by positive y is -y. And negative times by -9 is +9. So now if I add these together, basically if it makes you feel more comfortable, because there's not an x squared component up here, you can put in 0x squared there if it makes you feel more comfortable to think about how you're adding. For me, I just know that if you don't have a matching coefficient or like term in one equation, you just put in the one that's present in the other one. So -4x squared just stays the same because there's nothing in the other equation to change it. 3x plus x gives us plus 4x. Positive y minus y is 0. -9 plus 9 is 0. So we see that we end up with exactly what we had up here, 4x squared minus 4x equals 0. And from there, you would just factor the same way we did and then do your substitution to solve for y. Okay, so everything else is the same. It's just that basic beginning that you would start out with. That's going to be a little bit different. All right, so pause the video now and we have a system. I have a system set up for you that's exactly the same as the one that we just did in how they're set up. It's not the same number values. So try it using substitution, try it using elimination, and maybe just to check with your abilities, try solving it graphically too. So just go in and make sure that you can verify using a graph. And then when you're finished with that, we'll move on to our last two examples. All right, so our last two examples are both quadratic systems. One thing I forgot to point out in the previous section there was that, let me just see if I can pull that back up. With this one, so if you remember like solving by substitution, we could, in a linear system, we could choose either the x or the y variable to isolate in our first step here. Whenever you have a quadratic one, because you're going to have one equation that has two versions of the x variable, you always want to find a substitute for y, because what you want to be left with in the end is your quadratic that you can factor down further. Okay. So in this first one, I'll solve these two examples, one using substitution and one using elimination. So we'll start with the option of using elimination for this one. So in this case, we want to, same thing as what I just mentioned for substitution, what we want to do is get rid of the y. So we have two negative y's. So in order to eliminate them, one of them would have to be positive. Now the other thing to be aware of is that when you have two quadratic systems, you want to have them both set equal to 0 to make like the solution as simple as possible. So the first step we're going to do is make this one equal to 0, which basically just means we need to move this 4 over to the left side. It's +4, so we need to subtract it off. So this equation is going to transform into 6x squared plus 4x minus y minus 4. Okay. Then we want to, because we want our y's to be opposite, we want to multiply one of these by a negative. So let's maybe do this one. And so the first one will stay the same, 3x squared minus x minus y minus 2 is equal to 0. And then for this one, we're going to have negative 6x squared. Negative times by a positive is negative 4x. Negative times by a negative is plus y. And negative times by, sorry, I guess I should have technically done this around this one. Negative times by negative 4 is going to give us plus 4. And that will all be equal to 0. So now to work our elimination, we're going to add these two expressions together. So 3x squared minus 6x gives us negative 3x squared. Negative x minus 4x gives us negative 5x. Negative y plus y cancels out. Negative 2 plus 4 gives us plus 2. And so that's all equal to 0. So now we have kind of our familiar looking quadratic formula, and we want to factor it out. Because we have an a value, let's try using the swing method. So we're going to remove this negative 3 by multiplying it into the last term. So we're going to be left with x squared minus 5x. Negative 3 times by 2 gives us negative 6. If we want to factor that, two numbers that multiply to 6 and add to 5 would be 6 and 1. And we want it to be negative 5, so it would be negative 6 and positive 1. X minus 6, x plus 1. And then just remember, we want to divide out now that negative 3 that we used so that everything balances out. So negative 3, that leaves us with negative 6 divided by negative 3 gives us positive 2, so x plus 2. And this one is a fraction, so we're going to have move the negative 3, swing it up to the x. Negative 3x plus 1 will be our other bracket. Okay, again, in a test situation, you can always multiply that out really quickly to make sure that it gives you your original expression here. But we're not going to do that step right now. So now our values for x are going to be, remember this whole thing would be equal to 0. So in order to make that, each bracket would need to equal 0. So we would need a negative 2 for this one. And then just remember, it's always going to be the opposite sign for the fraction that's that you would develop by taking the final term divided by the a value for the x. So that would give us negative 1/3. So we need the opposite, which is positive 1/3. Okay, you can also do it, if you remember, we already covered that, by setting this expression equal to 0, and then when you solve for x, you should get 1/3. Okay, so we have our values for x. Now we want to substitute them into one of the equations to solve for y. So let's go 3x squared. Let's start with the negative 2. 3 negative 2 squared minus negative 2. Oh, minus y. Yeah, whatever. Let's just do that. Minus 2 equals 0. So a negative 2 squared is 4 times 3 is 12. Minus negative 2 is plus 2. And then minus 2, or minus y minus 2 equals 0. Let's move the y over. So we're going to add y to this side, and then we can add y to that side to cancel it out. So we're left with 12 plus 2 is 14, minus 2 is 12, which is equal to y. So our first solution would be negative 2, 12. Then our second solution, we're going to go 3 times by 1/3 squared minus 1/3 minus y. Actually, we know that we just need to add y to the other side, so I'm just going to go minus 2 equals y. 3 times by 1/3 squared, so 3 times by 1/9 is 3/9, which is just 1/3, minus 1/3, which is 0, minus 2 equals y, so negative 2 equals y. And so our final solution would be x equals 1/3, y equals negative 2. Okay, so those are our two solutions, and again, you can always go in and check those out graphically. All right, one more quadratic. Let's solve this one by substitution. So basically we want to pick, in this case we have both quadratics. I'm just going to choose the first one to isolate y. So basically I would add y to both sides, and I want it isolated, so I want to get rid of that one, so I'm going to also add 1 to both sides. So that's going to result in y being equal to 6x squared minus x minus y plus y cancels out, and we just have that plus 1 that we brought over from the other side. So y is equal to 6x squared minus x plus 1. Now I want to take that and substitute it in for my y value down here. So 4x squared minus 4x minus y. So minus y is equal to 6x squared minus x plus 1. And all of that is equal to -6. So now I want to start out by combining like terms. So 4x squared minus 6x squared gives me -2x squared. And then -4x minus -x, so basically -4x plus 1x gives us -3x. And then we have minus plus 1. So that's just -1 equals -6. Now we want to set this up so we can factor it. So we want to set it equal to 0. We want to bring that 6 over. So plus 6 plus 6. And that gives us -2x squared minus 3x. -1 plus 6 gives us plus 5, which is equal to 0. Okay. So now factoring again, we look at this, it's probably going to be easiest to use the swing method here, so jump that -2 over to the 5, which leaves us with x squared minus 3x plus 5 times by -2 gives us -10 equals 0. Two numbers that multiply to -10 and add to -3 would be, you want -5 and then plus 2 to get to -3. Equals 0. We use the swing method, so we need to divide out that number we multiplied by. So divide by -2, divide by -2, and that gives us, this is our fraction one, so we're going to swing that up. So we have -2x, and then -2x minus 5. And then x, positive 2 divided by -2 is -1. So x minus 1 equals 0. So in order to make that true, the solution would have to be 5 over 2. Now here we would have -5 divided by -2, which would be positive 5 over 2. So to make it 0, we have to have the opposite of that, which would be -5 over 2 as one solution. So basically -2.5, and then the second one would be if we had plus 1 here, so x equals plus 1. Then we would just sub in our values to solve for y. So let's go 6x squared, so 6, let's do -5 over 2 squared minus -5 over 2 minus y. Oh, actually, I'm just going to use this one. 6x squared minus x plus 1 equals y. So that's going to give us, this gives us like 6.25, I think, or something like that. So it's going to be, if we multiply that by 6, it's 37.5 minus 2.5, basically, 5 over 2. So that gives us 35 plus 1. Oh, sorry. Wait, what am I doing? Negative. So it's plus 2.5. There we go. So that's 40 plus 1 equals y. And so y is 41. So our first solution is x equals -5 over 2. Y equals 41. Then for our second solution, we're subbing in 1. Nice and easy. Y equals 6 times by 1 squared minus 1 plus 1, so basically 6. So our second solution is 1, 6. And again, you can go ahead and check that out on your graphing calculator if you need to confirm. So you guys have an assignment to work on. That's just these basic kind of solving systems. And next time we will get into solving systems of equations algebraically, just doing a little bit more in-depth stuff. So basically word problems. So I will see you in that lesson.